Alright, so now what we're going to do is we're going to relate the frequency and the period and another quantity called the wavelength to even another quantity which is called the speed of the wave, or the velocity of the wave. So the speed, and so we'll just use v. Okay, so we're going to relate all these quantities. You've just probably already seen the video on relating the frequency to the period. They're inversely related to each other. So if you know one, you can figure out the other, and vice versa. So what is wavelength? Let's go over wavelength. So again, if you have a wave that is oscillating in time, this time the x-axis is literally going to be distance. And so here we go. Here's our wave, and so this axis is distance x, and one of the things that we find out is remember the last time we talked about the time it takes to go from one part of a wave to where it repeats itself. This time we're looking for the distance that the wave travels. So the distance, we use the Greek letter lambda for a wave to go through one complete cycle. So like from the peak to the peak, the way I just drew it, or you could go from the bottom of the wave to where it happens again. So there it is. Or for example, right here where the wave goes from the positive x-axis to the negative. The positive y-axis to the negative y-axis, so it's making that transition, and then where does that happen again? It happens again right here. So all those represent one wavelength. And the wavelength, lambda, is measured in meters. Alright, so that being said, as far as what the wavelength physically is, remember the basic idea of how speed and distance and time are related is that the speed of an object, any object at all that is moving, as long as it's not accelerating, is equal to the distance that it travels, d, divided by the time, t, that it takes to travel that distance, assuming you're starting your distance and your time at 0. Well, in terms of waves, the distance that the wave travels to complete one cycle we call the wavelength, lambda, and the time it takes to complete one cycle is called the period, t. So we have a new equation that relates the velocity to the wavelength and the period. Okay, so the velocity of a wave, so now we're just talking about the velocity of a wave, is the wavelength, lambda, which is in meters, divided by the period t, capital T, which is in seconds. So the units of velocity, as we usually have in this class, are going to be in meters per second. Now, one thing that I want you to notice is I could rewrite this equation as, now I'm not really doing anything different here, lambda times 1 over the period. So I haven't really changed anything, right? That equation is exactly the same as that. But the reason that I did it that way is because we can replace the 1 over t by what it is. So that is the velocity is the wavelength, and 1 over t we know from a previous video is what we call the frequency. And this is the usual equation that you see for how velocity, what the velocity of a wave is. The velocity of a wave is very routinely measured by measuring the wavelength and measuring the frequency, multiplying those two quantities together, and that'll give you the velocity in meters per second. So let's do a quick example. Suppose our wavelength lambda is, I don't know, how about 15 0.7 meters. And our period, well, yeah, let's just go, we'll go with the period. So suppose the period is, oh, I don't know, how about 0.23 seconds. So it takes 0.23 seconds to complete one cycle. Let's calculate the velocity. All right, so of course there's two ways to do it. We can use this equation that we just talked about, and we could also, since it's given to us, the parameters for this equation is given to us as the wavelength and the period, we could use this form of the equation. We could just use this. We know that the speed is lambda divided by the period, and so now let's put these numbers in. So it's just 15.7 meters divided by 0. This doesn't look like a point, sorry. 0.23 seconds. And when we do the calculation, I get about 68.3 meters per second. Meters per second. All right, let's do another example. Okay, in this example, to make it a little different from the last one, we're going to be given that the frequency is 550 hertz and the velocity of this particular wave and is 344 meters per second, which I should mention, this is a sound wave. Not that that's important. You do the equation exactly the same. But anyhow, let's calculate two things. Part A, let's calculate the period, just for the heck of it, and part B, let's calculate the wavelength of this wave. Okay, so we want to know both of these quantities. All right, so let's get started. Well, the period is pretty simple. The period is just 1 over the frequency. So it's just going to be 1 over 550 hertz. And when I plug that into my calculator, it's a pretty small number. It is 0.0018, and it's a repeating decimal. 1.8. All right, and so since this is in hertz, 1 over hertz, is just seconds. So this is seconds. I'll write SEC. All right, so we've solved part A. That's part A. All right, let's work on part B. All right, so for part B, we have again we have the speed of the wave is 344 meters per second. That's meters per second. All right, and if we go back to the original information, the frequency was 550 hertz. And of course we have this equation, V equals lambda, which is what we're looking for, lambda, times the frequency. So we just have to isolate lambda. It's just a little bit of algebra. So we'll do that here. Remember, what you do to one side of the equation, you do to both sides. So divide both sides by the frequency. The frequencies cancel from this side. And then we clean it up a little bit. So this becomes lambda is equal to V over F, which I already have it. So let's put the numbers in. So it's going to be 344 meters per second divided by the frequency, right? That's what this says. and our frequency was 550 hertz. 50 hertz. And let's see, that should be hertz. All right. And when we do that, now notice one thing here, that you have meters per second divided by, hertz are just 1/2. So this 1/2 cancels hertz. So the answer, of course, is just going to be in meters. And so I get, rounding it, about 0.63, let's say. And that's a 3. And that would be meters. Okay, so that is part B, and that finishes up